Hi, Amber. We actually went over this question in class last week, but I'll do it again for you now here. This is not the same data that you have in your problem, so I want to make sure that you understand your problem is going to have slightly different numbers. So we've got 25 home voltage measurements. We want to construct a frequency distribution with 5 classes, which we showed down here. Start with a lower class limit, the first one of 122.6, which they already entered in for you, and we're going to use a class width of 0.2. So the first thing I'm going to do is I'm going to enter in my lower bounds and my upper bounds. So the lower bound, the class width is the distance from one lower bound to the next lower bound. So if I take the 122.6 and I add 0.2, that will get me the lower bound, sorry, let's do that again. 122.6 plus 0.2 will get me to the lower bound of the next class, so that's going to be 122.8, and then I consecutively add 0.2 to get each additional lower bound, 123.2, and then 122.4. All right, now let's do the upper bounds. So the upper bounds, the next class starts at 122.8, so I'm going to have this class end at 122.7. That ensures that every value that might fall in this range down here is going to go into only one class. And again, I'm going to add the class width again to get the next upper bound, which will be 122.9, 123.1, 123.3, and I noticed a mistake over there, 123.5. This should be 123.4. All right, now let's go to the data, and we're going to have StatCrunch figure out the frequencies for us. So I'm going to click here to open up the data set in StatCrunch. Now again, right now, StatCrunch doesn't know where to put, for instance, this observation, 122.9. I can tell it's going to go here. Now I could manually go through and count, but that would be a lot of work. So what I'm going to do is I'm going to create a new variable that tells StatCrunch each class to put the data point into. So I'm going to go to Data and Bin. I'm going to select my data, which happens to be in the volt column, and I'm going to use fixed bin widths, which I showed over there in my table, 122.6. And again, the bin width they gave me in the problem was 0.2. And then I'm going to include the left endpoint. That means in the first bin, the number 122.6 would be included. In the second bin, 122.8 will be included, and so forth. So let's compute. So now I've got a new variable, and on this variable, I can go ahead and make my table to get my frequencies. So I'm going to go to Stat, Tables, Contingency. I'm sorry, we can do frequency on this one, frequency. And I'm going to pick that new variable, and I just want frequencies down here under stat, so I'm just going to pick frequencies. So here's my frequencies, 1, 7, 10, 6, 1. I'm going to go ahead and fill those in, 1, 10, 7, 6, and 1. Check your answer. Oh, one of my answers is incorrect. Let's go back and take a look why. Where's my StatCrunch? Oh, I mixed them up here, that's why. Should have been 1, 7. Put them in the wrong order. There we go. And then there's a second part to the question, which I'll let you answer, which has to do with whether or not this appears to be a normal distribution. So again, we did go over this in class last week. If you watch the video, it's there. But here it is again for you to help you work this problem.